So let's start. And today I'm really thrilled because we are talking to someone who helped shape the internet as we know it, Paul Mockapetris. Thanks for joining us. As you know, Paul is a visionary inventor of the domain name system, a cornerstone of the modern internet, enabling billions of people and devices to connect seamlessly every day. And with millions of servers, and so far I have seen that there are 362 million of domain names, the system, of course, is a vital part of our digital world. So Paul, thanks a lot. It's great really to have you with us. And I'm very happy to welcome you for this session together with Jim. Originally, I was expecting that Jim and you will be in Paris with me, but this will happen another time. So without further ado, let me hand over to Jim for a short introduction and just to start questioning you about the DNS and your vision of how this has evolved.
Great, thanks. So Paul, I want to say welcome also, and thank you also for being part of this networking channel event here. We're really so excited to have you here. It's too bad we're not sitting together in Serge's office. I think actually you and I shared an office at the Links for one summer, or we were both there at the same time anyway. But it's nice to be able to get together virtually. So thank you very much for being here.
Happy to be here.
And I want to remind folks, Serge and I have a couple of questions to get things started to talk with Paul. But we have the question and answer down below. So, please use it. We'll relay questions and moderate those. But it's a great opportunity to talk with one of the real giants of our field. So, Paul, actually, before we get started, something that we found when we do fireside chats with folks on the networking channel is just to ask them a little bit about their background, in particular. When you got in, whenever it was you got interested in computer science, there wasn't a DNS and there wasn't anything even called the internet. So could you just say a few words, just a little bit more on the personal side, sort of how you got started, how you got interested in computer science and networking, who maybe some of your early influences were?
Well, sure. The way I got started with computers in general was that MIT, I was going to school in Boston, and MIT offered classes for high school students. A guy named Stu Madnick was teaching the class. He now owns a castle in Scotland. So I liked his style, and he got me into programming. And then I wanted to be a physics major when I was going to MIT. And around my junior year, they said, Paul, in order to make a little money on the side, you're being a very expert programmer, but you're not a very good physicist. Why don't you change? So that's how I got into computers. I think part of the roots of the DNS were my early experiences at MIT at what became the Media Lab, because at the time, Nicholas Negroponte and his happy crew couldn't really afford time on the big time-sharing machines of the day, Multics et al. And we had to tie together many mini computers with a single hard drive. And so building distributed systems, and in fact, I built a file system, which was my first experience with naming, where I made my first mistakes, which didn't get replicated into the DNS. So that's how it all got started.
That's interesting. So you come more from a computer science distributed systems background than say coming up through comms or communication. That's interesting.
Well, yes and no. I mean, like I said, Nicholas took a vacation one summer against his explicit orders. We built a distributed operating system. And I was also working part-time at IBM with virtual machines. So the whole idea of doing distributed systems was there. And then for grad school, I was with Dave Farber at UC Irvine doing the distributed computer system. And I made another mistake in naming when I was designing a new set of names for the next generation of that. And I learned from that mistake as well. So there was a bunch of back channel experience, so to speak, that I incorporated into the DNS design. I made the errors early before it mattered.
Interesting. Well, we all learn from our errors. And now I found out also we both have a background in physics. And for me, it was when I was a senior when I decided I wasn't going to be able to make a living as a physicist. And so I should go into computer science. But
Quantum electrodynamics 2 was the course that broke me.
I took that course. For me, it was Jackson's electrodynamics. But anyway, we're getting we're going a little bit far field. So let me turn things over to Serge.
So you were both very smart, just to change topic. And so Paul, I think for many, it's quite interesting to understand how did the DNS happen? Because it's such a fundamental part of the internet today. So of course, maybe some of us remember the times of the host.txt file, and later the release of the RFC 799 in September 81, which mostly addressed domains for email. And then in 82, Postel and Sue published the RFC 819, the domain naming convention for internet user application, which outlined the problem in more detail. So can you just tell us how the DNS got started, both structurally and organizationally?
Sure. From a personal point of view, I was actually working on TCP measurements, and I wasn't being very happy doing that. And so one day, John Postel came along and said, we need to think about a solution to this naming problem. Would you like to work on that? And I said, sure. And at the time, there was about 5 proposals about how to do it. And while I stole from all of them, I didn't adopt any one of them and built the DNS. I think, people always ask, how did you get this important job? And the answer to that is nobody really thought it was important. They thought it was a nice little problem. I think that, the usual history says something like, the DNS is there to solve the name to address problem. And in reality, that's not the case. The DNS was there to build a distributed database and do something far more powerful than that. Even in the original specs, I was thinking about basically having a domain name for every person in the form of an email address and encoding those in the DNS. That didn't come to pass. I always think that one of the missed opportunities in the DNS world is that we didn't think about how to build identities for people that were kind of more portable than email addresses. And I think today one of the outstanding problems in the internet is trying to figure out how to do identities. I think there's like 6 different efforts, and they all are competing against each other, but none of them I don't think is really broken through.
But that's interesting. So sort of almost like a SIM card, a DNS equivalent of a SIM card for individuals.
Yeah, I mean, once upon a time, I think that there's a lot of innovative ideas that could have been pursued and didn't. I mean, that's the history of a lot of things, not just the DNS. Although the DNS, I think, is the most visible part of the internet, of all the internet technologies, from a standpoint of the billions of people on the planet. Everybody sort of uses a domain name one way or another. Not that many people actually see TCP packets going past. And things like management protocols have disappeared. The average person has no idea what's going on. Computer scientists worry, networking scientists are interested in BGP and stuff like that, but none of that is visible to the average human.
So I remember, Paul, when you were in Paris once, we were discussing this, what's in a name? So what was in a name at that time for you?
Well, I think the other thing that people argue about is what names should look like. And at the time, there was a lot of arguments that the top level domains should be the names of phone companies or the names of countries or whatever. And I said, I can build the underlying technology so that it can be whatever you want. Hence, what happened with ICANN and so forth was, for a while, people didn't want to add new top-level domains. And they said, oh, it's going to influence the security and stability of the internet. 200 country codes later, people said, well, wait a second, the DNS doesn't know what a country code is. We've added 200. And it's still working. And I think that, led to the expansion. But today, a lot of the design of the namespace is, basically commercial kind of interests that are, duking it out. So, the DNS, I think, fulfilled its mission of having the namespace be whatever you want. And, I often think that it should be useful for more things. And there are some people that run private namespaces for peculiar applications, but that didn't catch on as much as I thought it might.
So we've talked about names and what a name, you just talked about what a name means and what some of the alternatives would be. It's interesting. A question I get a lot from students has to do a little bit more with the service model for the DNS, right? So, you're coming out of the distributed systems community, so sort of all about, consistency issues and how to maintain consistency in distributed systems. And yet there's this sort of very loose service model in terms of guarantees in the DNS. So no need for consistency among caches, no type of time-based global commit for changes in authoritative service and things like that. And so I'm curious, why was that model chosen? Why was that particular, if I could just say loose model chosen, rather than something that might be, I don't know, a little bit more, with stronger semantics and properties? And so were there other models that you and John and others were talking about, or was this just sort of the internet way to do it?
I hate to tell you this, Jim, but in reality, I think it was just the way my intellectual DNA had been structured. So, for example, I talked about at the Media Lab how we had multiple computers in a single hard drive, and we had a distributed operating system. Well, that had to be built in such a way that if somebody rebooted their machine, things wouldn't stay locked forever. So the whole idea about having global consistency had been built out of me in that and in virtual machine systems, where you wanted to make sure that there was no way for one particular part of the system to just infinitely block the rest. So, eventual consistency was certainly the aim point. And you could give a pretty 100% guarantee that you could meet that threshold, where if you tried for a higher threshold, you might not get the reliability that you wanted. And at the early days, there were a lot of people that were extremely skeptical about this whole idea about, you mean I can't run my computer if the system on somebody else's machine isn't working? People were extremely skeptical about this. I don't know. Today we take it for granted, but back then it was, I don't know about this. I want to be able to be the master of my own domain, so to speak.
Wow. I got to say, I'm a little disappointed. I thought you would say, oh, this notion of best effort service. And I don't know, way back then, even before it was sort of articulated, I saw that was the way to go. And so we wanted to go with sort of very loose semantics. And that's sort of the internet philosophy, which I think is true, but it sounds like sort of it's interesting how the needs of the users, inside the Media Lab drove some of those initial definitions. That's
Well, I mean, it was just kind of the way I was wired. I was also for a while a rocket scientist. And there you have this whole business about redundant systems. And if one fails, the mission still succeeds, even though they don't. I mean, you know, the space shuttle had the same problem where they had redundant computers and they had to vote. And, you know, so then, well, how do you guarantee the reliability of the voting mechanism? So, you know, too simple. I mean, simple, you can understand simple semantics. When you try and do something more clever, then the consequences of errors or, you know, parity errors in your memory get to be more severe. So I think we wanted semantics we could guarantee. I think that, you know, to address further, I always thought that people would add additional semantics and additional kind of update methods. The zone transfer method, I mean, one of the things that people say to me is they say, this business about just having zone transfers where you have to copy the whole database, that was kind of silly. You know, you should only have some mechanism for sending the changes. And, you know, in reality, the reason we had zone transfers was you absolutely had to have that to get the system off the ground, to get it running. And it would be good enough for a while. I mean, I always assumed that people would add some kind of incremental transfer kind of stuff. You know, there was a lot of blank spaces in the original design where I always assumed that people would add things. So that, you know, security and so forth was one of those. Right. You know, the end of the start of the DNS came for me when ARPA said, well, you know, this is a done deal. It's no longer research. And I said, hey, NSF, we can do some really cool things. For example, what we could do is we could build a distributed index of the whole internet. And we could, you know, keep track of it all in the DNS and so forth. And we could add some features to protect against misconfigurations and hostile attacks and so forth. And the NSF said, nah, we don't need any of that. Actually, what they said was, this was before you were there. So, you know, you had nothing to do with it.
I was still in high school. Come on.
Yeah, I mean,
college.
Basically, it was kind of interesting because the reviewers split a little bit, but they all said, interesting proposal, but he's crazy to think he could keep track of the whole internet. Interesting proposal, but what he should do is just fix bind. Well, you know, you know, and stuff like that. So NSF couldn't decide. I mean, I called them up and I said, well, is it a yes or a no? What is it? And they said they couldn't decide. Very strange. At any rate, meanwhile, you know, ARPA came back to me and said, how about we need somebody to manage some money we have dedicated to X500. And I said, that's like the enemy. And they said, well, you know, do you want to do it or not? And I said, okay. And so I put together a consortium to develop X500. We called it the Fox Project, which was either fielding operational X500 or the foxes running the hen house, whichever way you want to look at it. At any rate, ARPA people actually said, hey, you managed to slap together this consortium and the proposals and get all this done. Why don't you come here and be a program manager? So actually, when NSF couldn't decide, they called me back again. And I said, okay. So that's how I went to ARPA.
Well, it's interesting about that, what you mentioned about NSF. It's all about asking the right question at the right time, right? And
yeah, well, you know, to you know, think a little bit about Archimedes. The problem is that I had the lever, but I shouldn't have been trying to stand on ARPA or NSF. I should have been going off to the venture community. I should have been going to Sand Hill Road and see if I could get some money and take it into the commercial sphere. Because that would have been the right thing to do in 2020 hindsight. But, you know, history is different. One of the things I tell students is that they may or may not ever want to think about being a program manager. I think a lot of professors think, what a waste of time. You know, I could write 24 papers in that time that you spend off doing it? Well, first of all, there's a certain amount of doing service for the community that enters into it, but you get exposed to an awful lot of things. And I think, my advice to students is, in general, you ought to think about getting exposed to as many different things as you can, because, you at least know what's there and sort of how it works. So I wish, in a way, I had gone to Stanford and they would have compelled me to listen about how venture capital works. Or at least I assume they do.
Well, you mentioned program managers, and I also always encourage faculty, for example, to think about being a program manager in an agency, whether it's in the EU, whether it's NSF, DARPA, FCC. I mean, there are lots of opportunities. But anyway, we're going astray again. So, Serge.
We'll come back to your advice later, Paul. But almost by accident, at the last networking channel session, we had a fireside chat with Vince Cerf and Paul Metcalf, who at some point were discussing, how they decided the number of bits for the IP address or for the Ethernet address. So at your time, again in the mid-80s, you were faced also with a scaling issue. So were there design choices you made regarding scale that were either prescient or not sufficiently predictive, where the service will go or how it will be used?
Yeah, well, I mean, there's certainly, the big mistake or the thing that still surprises me is the fact that we're still worried about these 500 odd byte MTUs or 1,000 byte Ethernet frames or whatever. I had always assumed that the packet size would scale up with generations of technology. But, some of it is still around today. So that scaling issue is kind of still with us. I still think that the use of datagrams is an interesting choice, but if you're going to have fragmentation with datagrams, then I'm not sure, how we could have done that better. But it's obviously an unsolved problem, I think. There's still the issue of, Apple is famous, and Apple and Steve Jobs is famous for saying, floppy disks gone, RS-232 connectors gone, Ethernet plugs gone. We get rid of that stuff. And in the DNS world, backward compatibility is honored to a much greater extent than I think is reasonable, but it is what it is.
Okay, thank you. Maybe, Jim, we can switch to some of the questions. I see that there is already a list of questions, so maybe you can start, Jim.
Sure, I'd be happy to. So Paul, when just a comment, you mentioned Ethernet and backwards compatibility, and when we had Bob Metcalf on, I guess just 2 weeks ago, he commented that, well, Ethernet now looks almost nothing like Ethernet. Maybe the frame format, arguably, but he said what's been constant is the brand and the notion of openness that was associated with that. So I think everybody has to honor backwards compatibility, but again, think about this notion of what does it mean as things change? When is Ethernet not Ethernet anymore? I guess it's more of a brand and what it stands for more than the technology almost. That was his comment.
Yeah, the original DNS RFCs, people always say, well, why is there 2 of them? What I was trying to do was to encapsulate the sort of principles, or if you will, the way you would teach it in one of the documents, and have the other document be implementation advice, thinking that the implementation advice, first of all, could be subject to less scrutiny. That if you want to delay something in the IETF, put a lot of details into it, and then people argue with it forever. So, the whole idea was the principles might stay the same, but the implementation stuff would be revised. And because it was just implementation stuff, maybe there would be less friction about, or you could even put conflicting advice in there. Bob Metcalf and I once were both on a stage, and we were debating the relative merits of Ethernet versus the kind of token ring technology that we did at Irvine, and which got adopted by IBM. At any rate, it was kind of funny because looking back on that debate, Bob was arguing that, well, gee, this thick passive coax is good because you can just install it and tap it as you want. And it's like plumbing that you put in the walls and it's just there forever. And that's one of the great things about Ethernet, right? And well, I'm sorry, there is no plumbing for Ethernet these days. It's either fiber optics or the airwaves. It's kind of the things that matter in a standard and that stay the same. And Ethernet is just kind of the idea of the way it operates, I think. And the fact that you could upgrade, basically the spanning tree and the switching stuff that goes on to make Ethernet look like the Ethernet ideal that certainly evolved over the years. That's what's enabled it to scale. In the DNS world, one of the things that kind of disappoints me is that we haven't evolved. Like I said, I was always thinking that we would evolve to a domain name per person, or everybody could have, one or more domain names, perhaps one for your, home life and one for your day job and one for your next job or whatever. However you wanted to do it, you could do it. I think today, I wish that what we could do is have everybody have their own version of the namespace. And what I mean by that is that there's, a bunch of names that are only used to launch attacks. And there's a bunch of bad guys out there. So we've gone through this whole business about, well, okay, are we going to have a name server for the EU that protects us? Or perhaps your 8888 problem was Google attempting to protect you. But I think it's a concept that I'm surprised people have so much trouble with. I mean, my day job, just full disclosure at ThreatStop, is that we enable people to basically edit the namespace they see and edit the IP space that they see in order to shape their internet however they would want. And I think that's actually a concept that, this is like the brute force version. I think trying to figure out how to evolve your own personal namespace or your organization's namespace, I think is one of the things that people should spend more time on, but don't. Because I think that, as Bob says, there's Metcalf's law, right? Which is the utility of the network is sort of the square of the number of endpoints you can connect to. Well, I'm sorry, it's sort of the square of the number of good guys minus the square of the number of bad guys. I mean, that's really the part of Metcalf's law that's missing. I think we need to pay more attention to it.
Yeah, that's a really interesting comment about taking a common infrastructure and then personalizing it to what it is that you want to see. I mean, there's a lot of discussion about that, in the social media space, about who controls the algorithms about what you see. And you're talking about, well, who controls the algorithms for names and in terms of what you see. We've got a lot of people online. And one of the great things about the networking channel is people get to ask questions and we have commentary. Serge and I had a couple of other questions we wanted to talk about, but we thought it'd be good to take a couple of questions. So I want to remind folks that there's a Q&A function down at the bottom where you can answer questions, and we're going to be taking a couple questions from there. And that's probably we've got some comments that came in through chat also, but try to use the Q&A just because it's a little bit easier for us. So let me ask you the first question. This came from David de Andres Hernandez. And it's one of these, did you ever imagine questions, right? Which I think is an always interesting question to, ask people who have built such foundational technology. And his question, and then I'll add a question to it, is, did you ever imagine that DNS could be used for load balancing during its conception? You know, I might add then, did you ever imagine the DNS would be the core, a core mechanism in Akamai and used in CDNs, for example? So the general question is, did you imagine, I mean, you knew the very specific uses and the immediate pain that DNS could solve, but did you have a sense of these larger applications and uses?
Well, first of all, I think that when you build a foundational mechanism, if you can imagine all the possible uses for it, it's not a very interesting mechanism. You know, it should be extensibles in ways that you don't understand. For the specific question, I think I'll refer you back to, I think it's RFC 973 or some number like that, about the MX record for mail. And the whole design of the MX record for mail was about sort of load balancing. And the basic name server, multiple name server records of multiple name servers. And if one doesn't work, try the next one. I think is directly on point for this kind of thing. Obviously people could think about more and more complicated versions of that. As they have, so that, for example, the model that was set in the MX record, Craig Partridge wrote that RFC.
Right.
The model that was in there was extended to SRV and to about half a dozen other things. So that whole thing, that finesse, if you will, has been incorporated into later DNS work many times. So I think, the whole idea about redundancy and load balancing was kind of one of the axioms of the DNS.
How about later uses, like in almost orthogonal uses? So not so much extending the DNS, but using the DNS as part of another system. Take CDNs, for example, and trying to do localization and figuring out where to map, which server to map a user to. Was there discussion about that too, or other sort of placement type of uses?
I've asked the internet historians out there, but as far as I can tell, the DNS was one of the very early ones about, sort of having redundant servers and compensating for failures by just going on to a different path, sort of like is de rigueur these days in routing, for example. But, at the time, I don't think so. At the time, the whole idea is the way you got reliability was by retransmitting. A la TCP. I think the DNS was certainly one of the early examples, if not the earliest, in the internet technology suite for having getting that kind of reliability.
So Paul, I'll take another one from the Q&A from Dave Oran. And the question is, why do you think we never got an official working, vetted, standardized update protocol for the DNS?
I'm sorry, could you repeat that, Serge?
Why do you think we never got an official working vetted standardized update protocol for the DNS?
I'm not real sure, to tell you the truth.
Okay, so I'll move to next. I can come back to that later. So next one is from Eric Naum. If you could do it all over, it's a meta question. What would you change about the DNS?
Well, yeah, I mean, first of all, I certainly would have owned a bunch of premier domain names and wouldn't have to worry about it.
You'd be rich.
Dan Lynch once said I was the only person to invent a multi-billion-dollar industry and not really get a nice piece of it. That's certainly there. But I think that I would have pressed for evolving it and extending it at a faster pace. I kind of sat back and waited for people to do stuff, and particularly things like security and sort of more complicated searches. I mean, one of the questions I have, this is kind of meta question, is we have file systems and we have the DNS, and they sort of do the same thing. You know, should we be able to have some sort of single thing that does multiple? I mean, is there a reason to have separate things for databases and DNS and file systems? You know, I would have is there room for more complicated queries? You know, one of the things is that the queries were designed to be very lightweight, but you know, that also means that you get denial of service attacks. Could you have thought about that earlier? Probably not. I mean, again, the perspective at the time was what we were dealing with. And, you know, the whole idea about somebody else on the ARPANET attacking you, you know, wasn't really part of what we were worried about. But certainly, I did try to leave the door open for adding things like incremental zone transfer and security. And just sort of like today, you know, the security experts were telling me that they had a solution. Don't worry about it. You know, when it's time, we'll be ready.
Right. You know, I guess there have been a couple of comments about, say, security versus resiliency, right? And so even in the absence of malicious users and hackers trying to do bad things, the notion, and maybe it's tied in again with the sort of soft semantics, if you will, or the looseness of semantics. But I don't know, do you have thoughts about it's a pretty resilient system? Is that because of the way it's implemented in the sense of you know, multiple servers and redundancy and things like that? Is it resilient because of the sort of minimalist design in terms of semantics, both of those? It was just a general question about resiliency and maybe redundancy and as separate from security.
Well, I'll give you an example. I mean, it seems to me that by now we should have figured out a better idea than the root server system we have. I spent a year working for ICANN, kind of as their for-hire CTO. And one of the things we did was we did a study about how we might evolve the system over time. And we had a bunch of different ideas about replacing the root system with just a system for distributing copies of the root. You know, why worry about the root servers coming under attack when you could just distribute copies of the root to everybody if you wanted to? Maybe that's the mechanism. Mm-hmm. I also proposed a mechanism there where a particular zone could be controlled by a voting system, sort of like the way you do blockchain. It wasn't going to be, it was proof of stake rather than proof of work. But, you know, so, you know, you could think about having a domain that wasn't just top-down managed, but was managed by a consortium. Or you could think about, rather than, you know, the original mechanism in the DNS was go to the root and you can always go down at least one level, so therefore you can go anywhere. Well, you can think about maybe adding a mechanism so that you can always go up to the root as well as going down from the root. Or you could think about replacing any of those. Mm-hmm. And there's a current effort in the IETF for a thing called DELEG, which is supposedly a smarter version of the name server record. But it seems to be more targeted towards having more choices about which protocol you use to get from here to there. And I don't know, it's hard for me to be 100% certain that that's a great way to evolve things. So there's a bunch of the basic mechanisms, like how a zone gets replicated, how you find the right server to ask, you know, how you traverse the tree. We could have thought about ways to do that and replace the old mechanism on the root server system. Mm-hmm. There's a bunch of those that are out there that I think you know, you would want to consider. I think the last question is perhaps one for an economist, which is, you know, I went to the workshop at UCLA about, you know, the internet distribution and centralization kind of issues. is it possible to think about going to a more distributed, back to a more distributed approach? The economic interests are forcing us to centralization and are putting concrete around those systems to keep you from changing them. If you're going to evolve the internet to be back to being more decentralized, is it possible to think about doing it to a fundamental mechanism like the DNS? Or do you have to, as I think that particular conference discussed, worry about doing things about, apps and message passing? So evolving things like Signal or, the like. It's an interesting open question. And maybe it's just old guys like me just have a bias towards distributed systems, and we should stop worrying about centralization.
So actually, as you just touched base on those geopolitical and governance issues, because you have been addressing the questions related to blockchain-based DNS somehow. So I'm just curious to get from you how those geopolitical dynamics have influenced the operation and evolution of the DNS. You had this also discussion about TLDs and how you had to basically convince the different stakeholders about how you should, what you should put in a name.
Yeah, I mean, in the early days, the discussion was the international standard said country codes were the top. Okay. From a practical point of view, I always advocated about having top-level domains. One set should be the country codes, just so that I could tell them, here's your country code, go off and do whatever you want. You don't have to do the same thing as everybody else. And you can worry about achieving consensus if you want to between the UK and France about what domains underneath should look like. I think that that whole business, is a political dimension that weighs heavily along with the commercial dimension today. And I'm not sure I'm the expert to talk about it. I would note that in the early days, it worked out pretty well. But I think that today it's holding us back. I've noticed in the past, I've had a bunch of people who said, well, I like these, domains that aren't country code domains because there's no political baggage. If I want to sell goods around the world, nobody is going to be upset with me because I come from a particular place. And I think it's a good thing. Hey, Serge, there's one point I want to make while I still have an audience. I'm actually working on a paper about the early days of the DNS, so that if anybody out there has a question that they would really like to have answered, send it along. So far I've managed to talk to mostly people I know, and they have questions like, why dot? And I say, well, I didn't pick dot. That was somebody else's thing. But there's a lot of these questions about how the architectural discussions and how things got resolved and how they got designed. That anybody that has one, send it on. And if I ever get done with the paper, you'll get your answer.
And they can use the Slack channel that we have for that purpose if you want. But of course, they can also ring your bell directly if they wish.
Ray, when you were mentioning earlier about the political dimension of names and country names maybe holding you back, and then earlier you talked about everybody having their own name. When I think about the name adjudicating name conflicts and things like that, it's almost, my head explodes when I think about that, when you get down to individual names and things like that.
Yeah, I mean, there are people that kind of run to, well, names shouldn't have any semantics. They should only be like numbers. And then, but that's not what people want. Right. That's not what you're going to put on your business card. So I think, you end up having to deal with that kind of issue.
Yeah. Us
Um,
geeks like to go around and just, use our IP address actually, rather than our name.
yeah, I mean, should the top level domain Amazon be reserved for the river or the company?
Right.
I mean, I think there's no getting around that there's going to be, disputes there. It'd be interesting to try and figure out how to deal with both without having, two people that want the same name, but I don't think that's possible.
So what
Yeah.
about persistent names, Paul?
I'm sorry?
What about persistent names?
Yeah, I mean, that's one of the questions about how you could innovate. And first of all, there's what exactly does a persistent name mean? But I mean, one way to say it is, okay, can I just buy this name forever? And if you want, you'll put the money in a trust fund, which will pay the dues to Fireside, say, or whatever. And I'm sorry, I wish that, some country or some CCTLD had put together a proposal to do exactly that. I mean, one of the things is that you don't actually have to, the first part of, .com could be the site that hosts all persistent names. I don't care. It could be, a country code or whatever. Nobody has ever tried to set that up. I don't think there's any reason to believe that you couldn't issue it. And there's this question about, well, okay, what is the name going to look like and so forth. I once upon a time proposed, isn't there some way that what we could do is sequence your DNA and derive a number, and then you would own that number.dna, okay? And that everybody could have a unique ID based upon their DNA that would map to a domain name. And then, the people that manage the DNA top level domain could come to you and say, okay, you claim you own this. Do you mind if we take a swab and we'll get back to you tomorrow? Right. You could think about doing things like that. And nobody has. I mean, I think that people haven't really thought about a lot of the things out there that they might be able to do. There's a lot of history, by the way, in naming systems not related to the DNS, where I think the ideas translate. So, like a US standards organization invented barcodes. And as I understand the history, the EU or some set of Europeans came along and said, hey, we want a bunch of numbers. And the people in the US said, that's fine. What we'll do is we'll charge you, $5 million. And the Europeans said, I think we'll add a digit and encapsulate your namespace. All right.
Everybody gets layered on top of, right?
Yeah. And we'll encapsulate your namespace. And oh, by the way, we'll be selling those names. Yeah, that sounds a whole lot better. Instead of buying them from you, we'll create our own, encapsulate you, and then sell it to people. Yeah. And so that's what happened with barcodes. And there's a similar thing that happened with RFID tags. For a long time, I don't know whether they've resolved it yet, but the airline industry had one set of barcodes for aircraft parts, where maybe you really want to be sure that you can identify the provenance of your landing gear to make sure that it wasn't a knockoff made out of tin. They had a different one for bags that had been lost, and they had a different one for tickets. So, these whole ideas about evolving numbering systems have been around, and maybe there's something we can learn. Once upon a time, there was a proposal to put all of the RFID codes into the DNS. Some people at MIT actually came to me and said, hey, we're thinking about putting this, we're going to have billions of these numbers, and they're kind of hierarchical, and, we want to distribute ownership and so forth and so on. And I said, yeah, solve problem. Just use the DNS. Here, layer it on. And they said, great, we were kind of thinking about this, but we wanted to talk to you as an expert. But the standards organization for RFID tags didn't like that. They ended up not adopting that system, partially because they said, oh, no, you can't have these variable hierarchy delegations. And I said, no, we call them subnets, and we do it all the day. Every packet you send on the internet is susceptible to it. Don't tell me it doesn't work. Well, it works for 32-bit numbers, but we don't. What? You know, I mean, it's the commercial interests there, you know, did their thing. Okay.
Okay. We have a couple of wrap-up questions that we wanted to get to, and we've only got a few minutes left here. So maybe I'll ask you one, and let's see. For people of a certain age, you know, a lot of times one gets asked for advice, and or if you had to do it all over again, what would you do? I mean, those kinds of questions. So you know, again, in the networking channel, a lot of times we get a lot of graduate students and students and younger folks joining us. And so for that group, you want to pass on any sage advice to people? What worked for you?
Well, it isn't exactly what worked for me, but my advice is to do more reconnaissance. What I mean by that is, first of all, if you, day one, as a new PhD student, my advice for you is go to the library and pull the 3 most recent PhD theses for your department and take a look at them. That will set your expectation about what it is that you need to do in order to get your thesis done. More broadly, I would say, you know, like I was talking about before, you know, being a program manager for a couple of years, or understanding what it's like to be in the startup community or whatever, understanding those different spaces is my second piece of advice. And the third is that I believe that opportunity often lies right at the intersection of 2 different fields. So, for example, once upon a time, I got launched in a career of integrated circuit design because I could understand device physics being a physics major, and I could also program in Fortran. But, you know, like when large scale computing hit, you know, the bio world and DNA, you know, I mean, look for opportunities where 2 fields intersect and you have a certain amount of credibility in both of them, because most of your competition is eliminated because they only can do one or the other. And there's a lot of opportunity there. And I guess if there was one more, it's try to understand some underlying trends. So Carver Mead at Caltech beat into me this whole idea about scaling of integrated circuits and what commonly known as Moore's Law kind of stuff. So one of the reasons I was involved in early use of internet over cable was I was convinced that integrated circuits in digital signal processing would overcome the noisiness of a cable channel. That's a particular thing, but if you could figure out some place where there's no competition because everybody believes something that's wrong, that's a great place to go.
So a number of the things that you've touched on here have to do about understanding different fields. You know, you talked about understanding what's going on in Sand Hill, for example, or understanding different fields. A lesson that I took away from something that you said, especially when you were talking about the origins of the DNS, has to do with interacting with people and ideas that sort of emerge out of conversations. And I wonder if maybe in our sort of Zoom-based world, this is getting harder and harder to do. But you know, if you think back, your early conversations with John Postel and others, I mean, those things happened because you were there and you were talking to people about those kinds of things. And I somehow imagine that talking to people about ideas is and getting inspiration from them, and then, I don't know, synergistically ideas sort of form through these conversations. Is that something? Was that just like a one-time thing where that happened and it was like lightning for you and it was great because you happened to meet John at the water fountain or something like that?
I don't know about that. I think, technology means that I interact with more people in the average day rather than fewer than if I went to the office. I think kids today think about how to do this stuff in a way that's different from what we did. So I don't know. I'm not sure. I mean, I believe that there is value to, meeting people and, just discussing with them over a whiteboard or maybe a glass of wine. It's people will evolve to fit the new technology and vice versa. So I don't know. Is I guess the answer. I of course prefer the old ways, but I'm not sure I recommend it to the.
Well, I remember us sharing a glass of wine eventually, discussing clean slate vs evolutionary. And there is one question that will be the last question. This is in the Q&A. Do you anticipate any significant revolutions of the internet in the next decade? And what could that trigger for DNS evolution?
Yeah, I mean, like I said, when we were talking about the centralization issue, it's not clear to me how easily you can move the foundations these days. But, I believe I'm always optimistic about the future, despite, there's several reasons not to be so optimistic these days. I'm looking forward to it. Maybe it is that the message apps will be out there. I don't know. I just prefer to be optimistic because it doesn't seem like there's any percentage in the other side.
The alternative's no fun.
Yeah, the alternative's no fun. I mean, even if I'm wrong, I can be wrong and happy for several years.
We have no other choice.
I think there's a friend of mine who wrote a book, and I'm just going to tell you the title. The title of the book is Just Evil Enough, where he talks about how, success in industry is you have to be just evil enough, to get where you have to go, but not compromise yourself too much. And, I think that's an interesting concept. At any rate, thanks very much, guys.
Thank you so much, Paul. It was really a pleasure even to have you remote, but I expect that we'll have opportunities to get together soon. Thanks a lot. And again, I would like to remind to the audience that this session has been recorded, so please disseminate the information as it will be available on our YouTube channel in a few hours, I believe. And let me, as we just usually do, introduce the next session of the networking channel, which is scheduled in 2 weeks from now. So this is going to be on February the 19th. And is going to be basically a report on the DAX tool seminar that was held back in December. It's about experimentally driven research infrastructures, and tools for collaborative network system research. And we'll have on stage Jörg Garle from the Technical University of Munich, Kate Keehee from the University of Chicago, and Henning Schussrin from Columbia University, and myself. And we, of course, are looking forward to having you in the audience in 2 weeks from now. Thanks to everyone, and take good care of you. Bye-bye.
Thank you. Thank you, Paul. Thanks again.
Paul. Thanks again.
Thanks again. Bye-bye.